Alright, so today we're going to be looking at change, both physical change and chemical change. So we're going to put up here change. And just like we could have physical properties and chemical properties, we can have both physical changes and chemical changes. So in a physical change, alright, this is, we know a change has happened because something looks different. Water boiling. Alright, we have liquid changes to a gas, that is a change. Okay? So, in physical changes, we might just say that the particles involved in the change can reconstruct themselves. Alright, so the particles, which might be the atoms or the molecules, reconstruct to their original configuration. And they can just do this on their own. So reconstruct to their original configuration. So if we take, for example, water boiling, that's just going to be configuration right there. If we take water boiling, we have water molecule, which is H2O, which is 2 hydrogens and an oxygen. And if we boil that, it turns into steam. And what is steam? Steam is simply water, which is H2O, but it's now as a gas. Okay, so instead of those particles being really close together, we've separated them, but it's still H2O. So in this case, they didn't even have to reconstruct themselves back to their original configuration. They never changed. They just look like they changed because what we saw as water, now we don't see as a gas. Something else that might be a physical change would be if you put some salt in water. If you were to boil that water off and change that water into steam, what would you have left? You'd have salt crystals left. So in that sense, we have salt, we put it in water, and it looks like it disappears, but it's really just dissolving. But what happens to that salt once the water gets boiled out? It reconstructs itself back into salt crystals. Alright? So physical changes, whatever our particles are, they reconstruct their original configurations. Chemical changes, this changes the actual chemicals themselves, alright? So they cannot reconstruct. They turn into something completely different. Alright, so really with that, we want to look at what are some examples or things that usually mean a chemical change has occurred. Alright, and there's going to be 4 things which again signify that a chemical change likely took place. And the first of those things is going to simply be the production of bubbles. Alright? So we might just say gas bubbles. Alright? Another way to say this would be formation of gas. Alright? So gas formation. But when we make a gas, it's typically observed because we can see bubbles forming in some kind of liquid. Alright? This goes right against, though, water boiling. Because whenever we see water boiling, we see bubbles, but that's not air bubbles. It's actually water turning into a gas within our liquid, and it's just water vapor escaping from the water liquid. Okay? So typically, these 4 things typically mean a chemical change has happened, but they're not set in stone. Alright? The second thing, so we have gas formation. We're also going to have precipitate, which is, let's say formation of precipitate. Okay, precipitate. And a precipitate, you'll see this in a lab we're going to do in the next day or so. But a precipitate is when we have 2 liquids. Alright, they're going to be solutions, so there's something dissolved in those liquids. And we mix them together, and whatever's in those 2 liquids actually make a solid when we mix them. So just like if you think of precipitation, that's rain falling out of the sky. A precipitate is when we mix 2 solutions, and we have solid that forms and typically falls to the bottom. Right? But it's really formation of a precipitate, or we might just say a solid is formed. Okay, that's what the precipitate is. A solid from 2 soluble, which just means dissolved in water, 2 soluble solutions. Alright, so that's number 2. So we have gas formation and precipitate formation. So 2 formations, and we're going to have 2 changes. Our first change is going to be a color change. Alright, and this would be as simply as if you have hamburger and you throw it on the grill, it starts off pink. We grill it, and it breaks up those proteins and does stuff for those, mainly the proteins. And what happens to that meat? It turns from red into like a brownish, darkish color. If you have a banana, you peel the banana, it's yellow. What happens if you let it sit out for a little bit of time? It turns kind of a brownish color because it's being oxidized. So a chemical reaction is taking place. How do we know a chemical reaction is taking place? Because we have a color change occurring. Okay? So we've done 3 so far. We've got 1 left. Formation of a gas, formation of a precipitate, color change. And the very last thing is energy change. And this can be in one of 2 ways. Alright? So I've kind of cheated a little bit. There's really 5 things, but we're going to call them, they're going to be in 4 different categories. So energy change. And energy change can take place in one of 2 ways. The first way is the release of light. So we have some reactions that release light, and a chemical change is happening as that light is being released. And then lastly, we can also have the release of heat. We might say the release or absorption of heat. And this is how hot packs work, or cold packs. There's a chemical reaction that takes place, and that chemical reaction causes something to become either cold or hot. Alright? So again, 4 things mean a chemical change likely took place. Formation of a gas, formation of a precipitate, color change, or an energy change. An energy change can take place in one of 2 ways, either the release of light or the release of energy. And usually release of energy makes something hot, but it can also be absorbing energy, and that would be like a cold pack. Okay?